Today, what we're going to speak, we're going to speak about the R32, but very, very briefly. We have about 45 minutes, and I'll divide these 45 minutes between the R32 and the new and innovative product of Daikin, the Uru Sahara. And it just to give, when I built this training, I struggled what to put inside and what to keep out. Basically, I want to give you a better understanding why did the industry went and adopt R32, what exactly is going on, and try to smash a little bit of, there are a few mistaken beliefs that R32 is explosive and it's flammable, and it's very, very dangerous, and I'm going to prove you that R32 is not as worse as it seems. The other part of the session, we're going to speak about the US7, the new Uru Sahara Daikin air conditions, about the features and the benefits. Okay, first, why R32? We had developed from the R22 to the R410. Before the R410, we have a very, very short time of R47, and we have all the industry had a lot of issues with that. So we evolved to R410, and now we're introducing the R32. Basically, if we're looking at this diagram, it describes the benefits. So as much as the color is better features, you have better features. So first of all, no ozone layer depletion. The smallest global warming impact. So what you call the GWP, the global warming potential, is the smallest. We have the highest energy efficiency, reduced refrigerant charge inside the machine, and I'll explain why. More compact design possible. Acceptable safety level, A2L. A2L basically, if some of you are familiar with flammability, in the past we had A1, which is not flammable, A2, which is flammable, and A3, which is explosive, basically. Now we have introduced the A2L, which is slightly flammable, and I'll explain exactly what does it mean. And easy to recycle and reuse, which is quite important, because in the past, basically, if you wanted to examine whether a refrigerant is good or not good, well, you just took the refrigerant. Well, if I'm going to spill something to the atmosphere, what will it do? Okay, it will do this and this damage. But nowadays, we're looking at the whole life cycle of the refrigerant. So what will happen? How much will I affect the atmosphere while the whole life cycle of the product, and we'll see about that. Economical solution and easy to obtain. So at the beginning, we had the R32, which was the last one with ozone depletion potential. All the other ones didn't have any kind of effect on the ozone layer, but we still have the GWP. GWP basically means it's a global warming potential. But when I'm saying GWP 1,810, what does it mean? It means basically that if I'm going to introduce 1 kilogram of R32 to the atmosphere, the effect on the atmosphere will be as I'm introducing 1,810 kilograms of CO2. So the basic number is 1 kilogram of CO2, and the compare is how will it affect the atmosphere? So this one is 1,800 times more than 1 kilogram of CO2. So the next one was R407. It had a lower global warming potential. It didn't have ODP at all. And then we went backwards. Why? Because the R407 was just basically a disaster to handle. The mixture was not very stable, and if some of the refrigerant It was a mixture, obviously, and if some of the ingredients just vaporize into the atmosphere, we need to replace the entire refrigerant inside the system. We couldn't do a recharge of the system. It was very hard to handle. So basically, after a very, very short time, the system as a solution went to R410. And today, we have the R32. R32, you can see that the global warming potential was reduced into 675. So it is the best solution compared to all the other refrigerants. So if I'm looking, basically, this table sums things up. So this is the global warming potential, slightly flammable. If I'm comparing to R32, so cooling capacity 100%, this is have more cooling capacity, and we'll see it in a second. The COP is very, very much the same as R22. The pressure is very much the same as R410, and R410 basically, so this is basically means that we can use the same tools that we're using in R410. As you can see, basically R410 was combined from R32 and R125, and we can say that in the past 20 years in the East, they're using R32 for many years, so we have a lot of experience with it. It's not a new refrigerant. As you can see from the pressure and temperature relation, R32 and R410 are quite the same. This is the explanation about the energy. This is the Molière diagram, and this is just to remind you, this is the refrigerant cycle. So this is the compressor work, condenser, expansion valve, and then we have the evaporator. So this is the refrigerant cycle. R410 based, if you remember from your classes in TAFE, R410 basically, this is the amount of energy we're going to get in cooling. This is the amount of energy we're going to get in heating procedure. So for the same amount of refrigerant, so for 1 kilogram of refrigerant, we're going to get much more energy from the same amount of kilogram of R32, which leads us to thinner piping diameter, higher coefficient transfer, charge volume reduction, about 90% compared to R20, and internal volume reduction of refrigerant circuit, 30%, which basically means you'll have much lighter units to handle around the house. So if we're taking all the information I told you till now, so CO2 emission potential compared to R410. So this is the global warming potential. So I told you, this is basically R410. Every one kilogram of R410 equals to 2 tons of CO2 to the atmospheres, and R32 is only 675. And we're taking it and combining it with the fact that R32 holds much more energy. So for the same amount of energy, I will need only about 75% of R32. Combined together, basically, we're reducing the global warming potential to the same amount of energy by 76. This is the idea. As I told you, these days, we're looking at life cycle climate performance, which basically means that today we're analyzing the full life cycle of a product. From the manufacturing, this is the CO2 emission while using, and this is the CO2 from leakage, and how much do we need to put energy to recycle this refrigerant. At the end of life, we need to recycle the refrigerant, and this is the energy that we need to use for recycle. If we're seeing as a whole solution, R32 is the best solution because it's the easiest, is the smallest CO2 emission, has the smallest CO2 emission. I think this part is the most interesting part about the safety. Everybody is very, very interested about this part. R32 safety, first I want to say that This presentation doesn't replace any kind of very organized training about R32. You need to, if you want to do a little bit more study about it, you have here courses, and you can take them. Obviously, I just want to introduce and just give you a little bit more confidence in this refrigerant. So basically, the industry reference was described in the ERA Safety Guide, Flammable Refrigerant. This guide, basically, it's all for all the personnels involved: handling, use, storage, transportation, installation, servicing, and using equipment servicing product with R32. Strongly recommend read this manual, understand this one. Okay, generally speaking, the ISO 817 describes two types of refrigerants. First type is class A, and second type class B, so low chronic toxic, and class B higher chronic toxic. Obviously, R32 in all the most of the refrigerant that we're using in class A, so low chronic toxicity. All the refrigerant, basically, we can say that R32, generally speaking, R32 is not toxic at all. What may occur is that under certain amount of R32, we may have some breathe issue because it connects to our lung instead of oxygens. This is the idea. But compared to all other A-class refrigerants, so R32, R22, R410, R124, R32 is the safest. It's the number one safest compared to all 99 other refrigerants designed, designated in Table 5 in this ISO 817. Flammability, in order to have flame, we need to have a specific volume of basically R32 concentration. So the lower limit is 14 and the upper limit is 29. So if we have below 14% of concentration, we won't have anything because the mixture is too lean. If we have more than 21, the mixture is too rich to burn. But still, it's not an explosive, it's not flammable. I mean, we're going to see it. As I told you, we used to have only A1, A2, and A3. So A1 was non-flammable, A2 was flammable, A3 was highly flammable. And now we introduced the A2L. A2L basically means slightly flammable, which is combined. So R32, R1234, and R155, it is flammable. And compared to that, methane, butane, propane are all in this section. So you can see it's not even in the same area. Just to explain, and I'm going to show you a movie that was done in a lab, what exactly slightly flammable means, because there are horror pictures running around and saying, oh, R32. No, it's not from this. So just for you to know, this is propane. Basically, burning velocity, 43 centimeters per second. Heat combustion, so basically the energy that it holds, 46 megajoule per kilogram. Every kilogram of propane holds this amount of energy. A2, which is flammable, so it's about half, 23 centimeters per second, and it holds 16 megajoules per kilogram. Ammonia, just for compare. Ammonia, 7.7 centimeters per second, but it holds much more energy. Basically means it's a little bit more explosive. 19 megajoule per kilogram. A2L R32, you can see, only 6.7 centimeters per second. This is the burning velocity, and only 9 megajoule per kilogram. And again, you need to hold a certain amount of R32 inside the room, specific amount in order to a flame even to occur. Charging limit, again, all the systems are basically following, all the systems in Australia following the Australian standards. Basically, this safety standards describes for air conditioning, heat pumps, humidity, humidifiers, Its scope covers most of Daikin air conditions. And this standard specifies the limit of refrigerant. Again, just a brief description. So for the minimum, this is the minimum footprint inside the room. This is the maximum amount of refrigerant. As you can see, this is very large amount of refrigerant. So for 1.4 square meter of floor, we can put 1.22 kilograms of refrigerant. What I'm going to show you now, basically, it's what is the flammability of R32. This is a test in laboratory, and now we're doing R32 leakage to a room, so direct refrigerant to the flames. This is 400 grams of refrigerant. You can see that the flames are slightly burned. This is 800 grams. Most of the splits, most of the splits 800 grams, so this is the amount of refrigerant inside the room. This is an open flame. Please do not try this at home, please. And what you can see, basically, this is too rich to burn. What is burning here? The oil. What you see burning is the oil, and you'll see in a minute the R22, what's going to be. So this is R410. Again, open flame. The refrigerant is not burning. The oil is burning. And R22, which is quite nice because this is mineral oil, burns much better, smells much better. Once you smelled it, you'll never forget. Again, this is basically R22 and the oil is burning. And the other test I'm going to show you, basically, it's an explosion test. This is how you test if the amount of, how does a refrigerant going to behave if you have an ignition source, the round amount of ignition source, and what's going to be the result. So you have a chamber, 1 cubic meter, and then you introduce refrigerant, any kind of refrigerant or any kind of other substance you want to check. It reached the critical point in here, and then you have an ignition. Since you're in closed chamber, basically you have an explosive. So we're going to see a few tests. Again, just to give you better understanding how does this refrigerant behaves. First test, 300 grams in 1 square meter, open flame. Okay? Second test, 320 grams, again, open flame. Flame occurs, but not explosions. And the third test, please notice, the third test you are going to see is not R32. It's just to give me a comparison. The third test is 30 grams of propane. Tokyo University in Daikin. This is 300 grams, no ignition. As you can see, this is a 320 flames, but not explosion. Not explosion. Again, it should be under very specific. I just want, again, I'm going back a little. This test, again, this test is not R32. Propane, 30 grams of propane. So just for the comparison, look at the window, basically the window shuttered. Just for explaining, this is basically an explosive. This is for the part about the R32. Again, it was just a brief, very brief touch about the subject. You can have, if you want to have a full courses, you can have it here. You can come to us and try, and we have full day course about this issue. Basically, if you're going, none of you, as long as you're certified fridges, none of you should have any kind of issue with the installation. The installation is basically the same. You should use the same tools. You should vacuum the system. You should do basically everything the same. But you should take, just for yourself, the safety section and read it. Be aware that you need to do some safety, take care of yourself and take care of safety. And the second part I'm going to speak today, basically it's the R32 Refrigerant from Daikin. And the nice thing is Daikin took an extra step and designed basically a new air condition with one step forward. So new and improved features we're going to speak. I'm going to speak, and as an engineer, I'm going to tell you what is the nicest thing from my point of view. So I'm going to speak about aim of development, new and improved features, product range, specifications, options, and compatibility. Again, I'm not a salesperson. I'm going to just to show you features which I find interesting about this product. The basic idea, in Japan, I've been to Japan a few times, and there is like a gentleman contest between the companies. Each company, each of the large company wants to win, wants to introduce the new technology, wants to win, wants to have the best product. And I can tell you this is the best product. It has the highest ER and COP rating, so 7-star rating, first launch air condition with the lower GWP, global warming potential, and further improved for total climate solution, and I'll speak about the total climate solution. Highest efficiency rating, complete indoor solution. So the nicest thing about here, basically this unit, if you're all familiar with regular air conditioning, basically it treats with temperature. This unit treats temperature and humidity as well. Also has air purification and ventilation, automatic filter cleaning, improved airflow pattern to reach furthest corner of the room, pre-area intelligent eye, we're going to speak it, user-friendly remote, and the lowest global warming potential in the market. The nicest thing, this unit has a lower suction. It's a wall-mounted unit. Basically, a conventional unit sucks the air from the upper part. This unit sucks the air from upper and lower part. So we have a better air diffusion inside the room. So we have new sweep compressor to lower energy consumption, high-efficient semiconductor, energy-saving sharp edge fan, and I'm going to speak about it. Smaller diameter heat exchanger and double air suction to improve efficiency, which I find this is quite revolutionary because basically you change the way, especially in wall-mounted, the way that the air is circulated inside the room. So conventional model has only 3 lines. The new model has 5 lines, ability to conduct heat by 20%, and also we can control humidity inside the room. And I'll explain how we do it. It's improvement of the blade. So basically we have, if you're familiar with conventional cross-flow fan, basically you have a single blade. In order to improve energy consumption, Daikin divided this into a saw, basically it's called saw edge fan. Why? Because it cuts through the air like a saw. The problem is that when you do it, you save energy, but since you have a little bit of turbulence on the wing, you're going to have a little bit of noise. It's going basically 1.5 decibels up. So Daikin went through and basically put dimples, microscopic dimples, very, very small dimples on the blade in order to reduce noise. So 7% improvement, and we reduce the noise as well. We have better efficiency for our, so basically this unit was taking it a new step further, introduced a new compressor, designed a new compressor, and basically we have, compared to the R410, 50% more energy efficient than the other products in the market. Uru basically means in Japanese humidification without separate water supply. So basically the system uses the air from outside in order to produce humidity. Sahara, dehumidification without unnecessary cooling, powerful ventilation, flash streamer technology, and efficient cooling and heating. Humidification, basically, we have a humidification unit on the room, on the outdoor unit, and basically we absorb humidity from the outside and filter it, obviously, and introducing it to the room. The basic idea of humidity is to gain more comfort. I'll explain. At the winter, temperature can be high, but the relative humidity is low. Basically, when the relative humidity is low, the body starts to evaporate sweat from it, and the feeling is quite warm. This is why also you can feel that you have dry sore throat and dry skin, because basically all the sweat evaporates to the environment. What the Uru Sahara does, it increases the relative humidity. You can lower the temperature. As you can see from the thermograph screen, you still feel warm. Why? Because you don't lose energy to the environment. You don't start to sweat, and you feel much better. We can also control the humidification area. So we can put it into high dehumidification, so reduce a lot of humidity from the air. We can reduce the humidity, and we can do low dehumidification area just for partial part of the coil. The idea for dehumidification, again, just to get better feeling, because we have a lot of heat source inside the house. We have lighting, human presence, television sets, and the idea is just to reduce amount of humidity and allow the body to dehumidify himself. This is the other way around. If we are lowering the humidity, we're going to be a little bit more comfortable inside the room. Again, we can suck fresh air from the outdoor and introduce it to the room. The fresh air doesn't go directly to the outdoor. If you're familiar with regular air conditioning, for example, cassettes, basically what the cassette does, it connects to fresh air, and basically fresh air, if the air conditioner is not operating, fresh air is going to be directly introduced to the room. This unit, it cannot happen. Why? Because all the fresh air has to go through the coil. So we prevent drafts, even if we have fresh air inside the room. We have a fresh up technology. The idea is that the unit prepare the room. So about 2 hours before the operation, again, everything can be set from the remote control. 2 hours before the operation, the unit prepare the room for the user. Also, we have flash streamer of air purifying just to remove bacteria and dust from the room. Break pollens, very, very important. We have automatic filter cleaning. You don't need to manually clean the filter. The system does it for yourself. Brush removes the dust from the air filter and dust stored inside the dust box and dust box. In here, the idea is that the new design of the vane basically can put the airflow to the upper part of the room, and the airflow through the ceiling can reach further places inside the room. As you can see, again, this is a thermograph picture. If you're using conventional air condition, this is basically the air diffusing through the room. And if you're using Uru Sahara, again, the airflow is through here, and you're getting a better balanced, better leveled system. And conventional would reach only 6 meters, and the Uru Sahara would reach 12 meters inside the room. Again, temperature balanced, and the set point is around 26. Again, the room is balanced faster and even. Again, I think this one is quite nice. We have 2 points of suction. Conventional air has only the upper part of suction, and the Roof Sahara has 2 parts, 2 suctions, basically from the top and from the bottom, so it circulates better air conditioning throughout the room. Intelligent eye. Intelligent eye basically means it knows to detect whether we have people inside the room, and also can tell whether we're sitting in which area in the room we're sitting. So if you are sitting in this part of the room, basically the air conditioner doesn't need to take care of this part of the room. So we save energy, we just introduce air conditioning for the users. The other side is basically to energy save. So the unit works and everybody leaves the room. So if everybody leaves the room, after 20 minutes, the unit will, if we're in heating, it will reduce 2 degrees. If we're in cooling, it will increase 2 degrees in order to energy save. It doesn't stop, it only stops after 1 hour. Again, you can set it 1 to 3 hours, depends on your setting on the remote controller. The unit will stop. If somebody enters to the room, the unit will restart. Again, you can do all of it from the setting on the remote controller. All the idea of the design is just to give better solution for the end user. Again, you can see it if you're using warm zone, the winter, to introduce better comfort, heat in the room. Natural breeze airflow, this is quite nice because, again, some of the things we don't tend to think of them as important. But it seems, okay, basically this is why we have university. They're just investigating what is comfortable. And the idea is that breeze from the air condition feels artificial to people. When you have only one speed or only constant speed on your skin, it doesn't feel very comfortable. So basically, Daikin reproduced natural breeze. The idea is to give random breeze throughout the room, and you can see these spikes basically just to give better and more comfort feeling inside the room. We can do optimized installation. Basically, again, in the remote controller, you can go and set the setting of the remote controller. And again, as I started, the idea here is to save energy. And this unit is much more efficient than all the other units in the industry. The idea is to consume less energy and obviously pay less electric bills and to have lower global warming potential to the unit. This is for today. Again, you can contact us if you want to have a bit more and better understanding about our units, about installation.
I just want to thank again Daikin for being here. You've been great sponsors for us, and we appreciate all you guys have done for the Box Hill Institute.
Thank you.
Thanks, guys. Thank you. Cheers.